All right, so today we're going to put all the pieces together. So, yesterday you drew a triangle, and I told you that R would eventually represent a radius. When we talk about a unit circle gets its name because its radius is 1 unit. So we're going to put its center at the origin, radius 1 unit long, and then remember if we have that point at the top we talked about yesterday, we can name the bottom leg X and the side leg Y. Now, whether you want to use the alternate definitions from yesterday or SOHCAHTOA, you can, from this picture on the unit circle, find sine, cosine, and tangent. All right, so for sine, I would do opposite over hypotenuse, which would be y over 1, and that simplifies to y. Cosine would be adjacent over hypotenuse, x over 1, which simplifies to x. And tangent would be opposite over adjacent, or y over x. I want you to write those 3 pieces of information on the corner of your unit circle somewhere. Okay? So sine of theta is equal to y, cosine of theta is equal to x, and tangent is equal to y over x. You might even want to put that sine and cosine information together. And we're going to say any point on the unit circle will have the following coordinates. The x coordinate is cosine theta. The y coordinate is sine theta. It's easy to remember because they come in alphabetical order. Cosine before sine, c before s. Okay, so just put that in the corner somewhere. Now, once we have those, we know we can get cosecant, secant, cotangent, right? We can take these sine, cosine, tangents and just flip them. All right, so what we're going to do next is we're going to take the unit circles that you have and we're going to add all of our points, which are going to represent our cosines and our sines, to each of those measures. So I have a unit circle on here. Oop, too far. Come on, go back. Oh gosh, it doesn't like that slide. Maybe? There it is. Okay. So I'm just going to throw my degrees on there real quick. These should already be on yours. 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330. Okay, so next to each of our degrees, and you guys have the radians also, we're going to put our coordinates. Now remember, this is a unit circle, which means radius 1. So we're going to start with our 0, 90, 180, and 270. If I am 1 unit to the right of 0, 0, what point is that? It is the point 1, 0. Good. Okay, if I am 1 unit up, what is that point? I'm at 90 degrees. So from the origin, I go 1 unit up, 0, 1. If you're at 180, that means you've gone 1 unit to the left. What coordinate is that? -1, 0. And then 270, I go 1 unit down from 0, 0, and that takes me to 0, -1. Good? Okay. Now, we're going to fill out 30, 45, and 60. The numbers that I'm giving you, I'm not pulling from nowhere. If you look at your notes from, what was it, the beginning of 5-2, do you guys remember we did the 30, 60, 90 triangles and the 45, 45, 90 triangles, and we found all the trig functions? Okay, so that's where these numbers are coming from. I know that the x coordinate is the cosine and the y coordinate is the sine. So if I'm looking at 30 degrees, for example, the cosine of 30 degrees will give me the x coordinate, and the sine of 30 degrees will give me the y coordinate. And if you look back at your notes, the cosine of 30 degrees we found to be rad 3 over 2, and the sine of 30 degrees we found to be 1 over 2. For 45, the sine and cosine that we found before were both rad 2 over 2. And for 60, that one was the complement of 30. So this is where that cofunction property comes in. That's just 30 degrees switched. 1/2 rad 3 over 2. Okay, so if you know nothing else from the unit circle, you want to know quadrant 1. Because quadrant 1, those points, we're going to reflect around the circle to get the remaining points that we need. If I take a point in quadrant 1 and I reflect it over to quadrant 2, what part of the point is going to change? The x is going to change. The x is going to go from positive to negative. That's all that happens. So we're going to take 60 and it's going to reflect over to 120. 1/2, rad 3 over 2, but the x is negative. So we say that 120 has a reference angle of 60. Remember we talked about that yesterday. It's 60 degrees from the x-axis, which means it's going to have the same trig functions as 60. There's just going to be a sign difference. Take 45, reflect it over to 135, rad 2 over 2, rad 2 over 2. The x is negative. And then take 30, reflect it across. I'm going to have rad 3 over 2, 1/2. My x is negative. Okay. To get quadrant 3, you can take quadrant 2 if you want and just reflect it down. So 150, if I reflect it down, rad 3 over 2, 1/2. If I'm in quadrant 3, what are my signs going to be on my point? Both negative now. Okay. If I take 135 and reflect it over the x-axis, I end up with rad 2 over 2's at 225. Both are negative. 240 will give me 1/2. Rad 3 over 2. My x is negative. Okay. And then to get quadrant 4, you can either take 3 and reflect it over the y-axis, or you could take quadrant 1, that's probably what I would do, and just reflect it down over the x-axis. So if I reflect 30 degrees down over the x-axis, 330 will be rad 3 over 2, 1/2. What's negative if I'm in quadrant 4? The y's. Rad 2 over 2, rad 2 over 2. The y is negative for 315. And then for 300, 1/2 and negative rad 3 over 2. All right, so make sure you've got that filled out. I'm going to take a second and put all my radians on here also because I didn't have those. 0, 2 pi, pi over 6. You can double check your numbers if you want on these. Pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6. Oops, that's a 6. 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 6. There we go. Got them all in there. Okay. Does everyone have a complete filled out unit circle? Now, points, radians, degrees. Great. Okay. What is the sine of 150 degrees? What is the sine of 150 degrees? Perfect. I find 150. I know sine is the y coordinate, 1/2. Okay. What is the cosine of pi over 2? 0. I find pi over 2. It's at 90 degrees. Cosine is my x coordinate, 0. What is the tangent of 315? What do you have to do to calculate a tangent? What was the little formula you wrote in your corner? Y over x. That's also sine over cosine. That's our quotient identity we wrote down in an earlier section. So for any of these points, 315, find it, divide sine over cosine, or y over x. If I do negative rad 2 over 2 divided by positive rad 2 over 2, what am I going to get? -1. Make sense? Okay. What if I want the cosecant of 270? Cosecant of 270. What's cosecant the reciprocal of? Which function? Sine. Cosecant is the reciprocal of sine. So I want to find the sine of 270 and flip it. What's the sine of 270? -1. The reciprocal of that is -1. What is the secant of 2 pi over 3? -2. So we find the cosine, its reciprocal, which is the x coordinate, and we flip it, -2. What is the cotangent of 2 pi? How are we going to get a cotangent, do you think? Yeah, if tangent's y over x, cotangent is x over y. You can write that one down if you want to remember it. So for 2 pi, I have 1 and 0. If I do x divided by y there, 1 divided by 0, what do we get? Undefined. Okay, if you guys did unit circle in the past, did you memorize this unit circle? Like, did you have to fill it out ever? Okay, so I will never give you a filled out unit circle for the rest of the semester. I will never give you one. I will give you a blank one, and it's pretty much going to look like the paper you have in front of you. It's going to be a circle with some lines on it, and you can write whatever you want on it. I will never grade a unit circle. I don't care what you write on the unit circle. But all those questions I just asked you, those 6, that's what we're going to be doing for the rest of the semester, where you need to be able to locate a point, and you need to be able to use that point to find one of the trig functions. Okay, so the circle itself, memorizing it, that's not necessarily going to be in your best interest. It's going to be more so recognizing the patterns and understanding how to find something. Now, patterns you can see on here, we talked about before with the angles, how to fill those out. With the radians, you can count by 1/6 and 1/3 and 1/4. So that's a strategy for the radians if you're not sure. I mentioned if you know quadrant 1, you pretty much know everything else, right? All you have to do is change the signs of those points. Another thing you can think about, if you don't want to like write all these points down, if I was at, I don't know, 210 degrees, how far away from the x-axis am I? 30 degrees. I use that point. All I have to do is change the signs. Okay, so I don't have to write the whole thing out, and that would not necessarily be the best use of your time, like write the first 5 minutes of every test the rest of the semester where you just fill out a unit circle. It's more so being able to look at it and say, okay, if I'm at 240, well, I'm 60 degrees away, and I know what 60 is. All I have to do is change my sign. Okay, so what we're going to do next is we're just going to practice using this unit circle to answer questions. Your quiz on Tuesday that's coming up will be 30 questions like the ones I just asked you, and you're going to have 1 minute per question. I will give you a blank unit circle, and then every minute I'm just going to pretty much change the slide on the smartboard, and you're going to have 1 minute to answer that one, and the next, and the next, and the next. And there will be no partial credit, no notes, no calculators, zip, your brain only, and a blank circle in front of you. Okay, so the rest of the period today and Monday, all we're going to do is practice. And I'm going to show you some resources in Polaris, some links that I posted for you that you can practice on your own too with this if you want to. Are we excited yet? Okay, great. So I'll show you those later. All right, let's practice maybe like 2 or 3 of these together, and then I'll let you try some on your own. Okay, you guys can do these on the back of your circle if you want to. All right, so sine 7 pi over 6. Okay, so you need to be able to mentally figure out where is 7 pi over 6 at. Those of you that remember with the fly swatters that day, my non-sophomores know what I'm talking about. 7 pi over 6 is here. Okay, so what point is that? How far away from the? I'm 30 degrees away. Okay, so your 30 degree point is rad 3 over 2, 1/2. Oh, there's a way you can remember that too. Hold your hand out like this. Okay, 0, 30, 45, 60, 90. Every finger is your quadrant 1, okay? Hold down 30 degrees. I have a 3 and a 1. Rad 3 over 2, 1/2. Hold down 45 degrees. Your middle finger. I have 2 and 2. Rad 2 over 2, rad 2 over 2. Hold down 60 degrees. I have a 1 and a 3. 1/2, rad 3 over 2. So that's a quick way to remember it. Another way to remember it, if you have a coordinate, you can think long, short to get to that point. Long is rad 3 over 2. Short is a 1/2. And we know if it's at 45, it's isosceles, right? medium, so rad 2 over 2, rad 2 over 2. So there's some ways to figure out what the point is without having to even write it down if you want. Okay, so sine 7 pi over 6, we said it's 30 degrees away. My point at 30 degrees is rad 3 over 2, 1/2. Sine is which coordinate, x or y? Sine is y. The y coordinate is 1/2. Only difference is I'm in quadrant 3. So if I'm in quadrant 3, would a y coordinate be positive or negative? It would be negative. Negative 1/2 is your answer. Okay. Let's do cosecant 4 pi over 3. Okay, so cosecant 4 pi over 3. Where's 4 pi over 3? What quadrant? Is it bigger than 1 or smaller than 1? It's bigger than 1, right? So it's got to be past 180. That's where 1 is at. So it's in quadrant 3. Okay, it's right here. How far away from the x-axis is it? 60 degrees. Put your finger if you need to. Hold down 60 degrees. It's 1 and 3. Cosecant is the reciprocal of which function? Sine. Sine is which coordinate? My y. So I'm going to take the reciprocal of my y coordinate, which is, instead of rad 3 over 2, 2 over rad 3. But I'm in quadrant 3, so will my y be positive or negative? Negative. Only thing that's left to do is rationalize. Negative 2 rad 3 over 3. Let's do one more. 8 pi over 3 is not on our unit circle. It's bigger than 2. So what do we do if we've got something bigger than what's on our circle? What do you think? Or something that's smaller than something on our circle? Yeah, we find a coterminal angle. We add or subtract a full rotation. If it's in radians, we have to first subtract 2 pi, which, if you don't like the 2 pi, you can make it 6 pi over 3. So we are finding the tangent of 2 pi over 3. It's equivalent. All right, so 2 pi over 3 is in quadrant 2. How far away from the x-axis am I? 60 degrees. There's 60. It's 1/2 rad 3 over 2. Tangent, how do I find it? Y over x. What's the y coordinate? Rad 3 over 2. What's the x coordinate? 1/2. And because we're in quadrant 2, we know the x is negative. The only thing you have to adjust are pluses and minuses when you're in those other quadrants. What happens there? 2's cancel. So final answer is negative rad 3. All right. There are 7 more problems on the board. Work with your partner. You guys want to work together maybe? And make a group of 3, whoever you want. Go ahead. Try the other 7. I'll give you a few minutes. I've got a couple more sets up here we can practice with. Monday, we're just going to play games practicing this too. That's all we're going to do. All right, let's see how you did. I put the word for those. 10's tricky, it's undefined. Reciprocal of 0 is undefined. What questions do you have before we do a few more practice problems? None? How'd you do if you had to give yourself a grade, like A, B, C, D? Where are we at? Middle range? Maybe B? I'll take it. C even first time? That's okay. I'm good with that. No F's, hopefully? No? Okay. All right. Let's try one more set. Okay, and I'm going to give you exactly 10 minutes. You have until 9:55. So let's pretend this is like quiz-like scenario, okay? See what you can do without the circle, maybe, for 5 minutes, for a couple of them. And if you need the circle, flip it back over. Maybe that can be your goal for this weekend, is get a little more comfortable with your circle, okay? So 10 minutes. Let's see, and then I'll show you what's in Polaris if you want to start practicing this on your own. For the quiz, these are either right or wrong. There is no partial credit. If you miss a negative sign, wrong. If you didn't reduce, you're radical, wrong. If you didn't rationalize, wrong. We're not joking around with the unit circle in here. Does this make sense with the rationalizing stuff here, guys? Multiply by rad 2 over 2, and then you have to cancel the 2's. Here, the 2's cancel, but you still have to rationalize. There's a little simplifying you have to worry about on those ones.
What if for number 7, if we had a 1 like next to the negative, that'd be alright.
If you had a 1 next to the, like -1 rad 3, yeah, that's fine. That's okay. Any other questions? Okay, so let me show you what's in Polaris, and then we're just going to practice this more on Monday. That's all we're doing on Monday. In Polaris, I put everything in next week's folder, okay? So if you open up week 3, you go down to where it says class materials and handouts. Here's what's available to you. There's a lot of different options. First option is this website that you can go to. When you go to the website, it'll ask you for some like setting options. Just choose these setting options, and it will just continuously throw questions at you. The only bad thing is it might not be rationalized answers. Like instead of rad 2 over 2, you might see 1 over rad 2, which is equivalent. Okay, but they're multiple choice, so it'll like kind of fast fire them at you, which is kind of nice. You can practice as long as you want. I put on here the next document. Again, this is all optional. Is just a worksheet that you can practice with. The first few are pictures. The last ones, you can see there's just a ton of questions, and there's also an answer key at the end of this document if you want to check it. The next 2 links are Quizlet links. One of these is all the radian degree, or all the radian measures, and the other is all degree measures, and it's just going to give you flashcards. Sine of 240, tangent of 5 pi over 3, over and over again with, again, 1's degrees and 1's radian. Trigraphic degree, don't have to worry about right now. We'll get that later next week. Okay, but that's some options. And then on Monday, we'll probably do a Quizlet. We might do like something with the fly swatters again. I have a book it. We might play a little bit. So we'll just do a few different ways to practice. But please, please, please practice with this unit circle. Know your unit circle. It's so, so important for the rest of the semester. Okay? Have I emphasized that enough? Get my drift? Okay, good. All right, that's it for today. Remember your 5-2 math exiles due tonight. Cell phone lotto winner is 4.
I'm rubbing that in.
Somebody is in there.
Don't even try and take my spot, Julia. That's my role.
How do you want?
Someone took my spot. I literally took my spot and then. Thank you. And I need to grab my mentor's stuff.
Okay. Let me stop this here.